All right, so we're going to start a new chapter, chapter 3, and this first section is on quadratic functions. So before we start with quadratics, let's define a polynomial. So a polynomial has this form where we have a sub n times x to the n, and we go on down until we get to a sub 1 times x plus a sub 0, which is a constant. And the key part with polynomials, just kind of generally speaking, is the exponents of the variables have positive non-negative integers, we should say, because they could be 0, like with the constant. But no negative integers, no fractions, no square roots, nothing like that. No x's in the denominator, anything like that. So that's those, generally speaking, are polynomials. Now, in this section, we are going to look at quadratics, and quadratics have degree 2, which means the highest exponent is a degree or is a 2. So we have ax squared plus bx plus c. Now we can write this in a different form called standard form. And that's where we convert the ax squared plus bx plus c into this form, a times x minus h squared plus k. And this will give us what's called the vertex. And so we have the graph of a quadratic, or a parabola is what it's called. The graph is called a parabola. And the highest point or the lowest point is called vertex, and that's given by this ordered pair hk. So we get that from this formula. And it says done by completing the square. You can do it that way if you like. I'm not going to talk about that method. We'll do it a different method. If a is positive, so if this number is positive, the parabola is going to open up. If that number is negative, the parabola will open down. So the homework in this section is mostly the same thing kind of over and over again. We'll be doing basically these things that are in this example. So the first one, 2x squared minus 12x plus 23, we want to write that in standard form. And the way I'm going to do this, so we have a is 2, b is negative 12, c is 23. And we can find the h part of the vertex by using the formula negative b over 2a. And so in this case, b is negative 12, so negative b would be positive 12 over 2, and then times a, which is 2, and then that gives us 3. So that is our h. Now to get k, we just plug in h in to f. So we have 2 times 3 squared minus 12 times 3 plus 23, and we get 5. And so our vertex is going to be 3, 5. Now we can write in standard form. So we have f of x. The a is going to be the same. So the a in this form is 2. The a in the standard form is also 2. So that will always be the same. So it's the same a. X minus h, which is 3 squared, and then plus k, which is 5. And so that is our standard form. So now we have the vertex. We need to find the x and y intercepts. So the y-intercept is very easy. The y-intercept we just find by plugging in 0 for x. So just find f of 0. And if you plug in 0, these first two terms cancel out, and we have 23. So the y-intercept, which is normally written as an ordered pair, would be 0, 23. Then we can find the x-intercept by setting the function equal to 0 and solving for x. And I don't think there's a way to factor this one. So we'll just use a quadratic formula. And so the quadratic formula we can use, actually there's an easier way. Let's do it the easier way. Let's set this equal to 0. So let's not do the original form. Let's set this one, the standard form, equal to 0. I think that will be easier. So 2 times x minus 3 squared plus 5. So we bring the 5 over. We have negative 5 equals 2 times x minus 3 squared. Divide by 2, so negative 5 halves equals x minus 3 squared. And now we actually run into a problem here because we have this term is squared, which means it has to equal a positive, but doesn't equal a positive here. So no x-intercept in this case. And if you're graphing this by hand, if you're kind of doing this as you go, you would recognize there's not going to be an x-intercept because we graph the vertex 3, 5. So that would go right there. We know that this one opens up because the positive coefficient there. So it's going to look like this. So nowhere is it going to cross the x-axis at all. So in order to graph this, we need to plot one more point if you're doing it on the computer, or 2 more points if you're graphing by hand. And the easiest way to do that, we have the y-intercept, which is 0, 23. So that would be right there. And now this is symmetric. The graph is symmetric. And so we've gone down 3, and that takes us to 23. Or not down, we've gone from 0, we've gone 3 units to the right. If we go another 3 units, then that one also has to be 23. And you can check that. If you plug in 6 to this, you will also get 23. And so there is our parabola. And of course, it goes up, keeps going past those points. But that's probably the easiest way to find it. You could pick any 2 x, like you could pick 2 and you could pick 4 if you like, or 1 and 4, any 2 points that are on either side, and that will give you enough information to graph it by hand. But on the computer, you really just need the vertex and the y-intercept, and that would be enough. So then what's the domain and range? The domain of these is always all real numbers. There's no exception to that. In fact, all polynomials, the domain is always all real numbers. So negative infinity to infinity. The range for a quadratic is never all real numbers. The range for the quadratic would be, in this case, find where the bottom is, which is 5. We're always going to include that number, and then we're going to go up to infinity in this case. So the range is always has either a negative infinity or a positive infinity, never both. It's never all real numbers. And then we come up or down to a number, and that number always has a bracket. So it's very easy to tell from the graph. So wherever the vertex is, 3, 5 in this case. So that will give you either the top, the max, or the min, depending on if it opens up or down. All right, so we'll look at some more examples in the next video.